All right, question 5 from the 2017 A-level paper 1 from AQA. So here we go. We've got two forces acting on a uniform ladder resting against a vertical wall. This ladder is at an angle of 60 degrees to the ground. Explain how figure 7 shows that the friction between the ladder and the wall is negligible. It's showing that it's negligible, basically because we've got the resultant force is at 90 degrees. Okay, so because the resultant force is 90 degrees, that means that all of the force is coming out of the wall and there's no vertical component. If there was a vertical component, it would be angled up, not at 90 degrees, not normal to the wall. So okay, so if there was some component of friction, it wouldn't be at 90 degrees. It would be 89 or 85, depending on how much friction there was. Okay, so you have to have a resultant force from the ground. Okay, so it has to balance out the resultant force here, and it has to balance out the weight. So it has to have some vertical component and some horizontal component. So it needs to have does it say label it G? Label it G. Don't make that mistake. Okay, so G. So because it has to balance out the weight and the resultant, we don't know what angle it actually will be at. It doesn't have to be at 60 degrees. But we know that there is some component here that's balancing out that resultant and some component that is balancing out the weight. All right, the ladder is 8 meters long and weighs 390 newtons. Calculate the magnitude of the resultant force from the wall on the ladder. So, what we know is that this is 8 meters, and we know that this here is 390. Okay. So I'm going to erase. Oops. I'm going to erase my pen markings just so that we know exactly what we're talking about here. So 390 newtons down. This is 8.0 meters long. Okay, that means that this is 4 meters. So I am going to take my moments about G. Okay, so this here is my moment arm. That's my moment arm. So this moment is going to be 390 times 4 cosine of 60. And here, this moment arm, okay, I gotta look at this angle here, also 60. The vertical distance, so it's sine 60, or actually cos of 30. has to equal resultant times 4 sine of 60. Oh no, not 4, 8. What am I doing? What am I doing? Ugh. So, that was almost a big mistake. I'm taking my moments, so I actually need this length here. Because that's the moment arm. And that's 8 times sine 60. So R is 390 times 4 cos 60 divided by 8 sine 60. Let's see if that's going to work. Oh, it's 390. 113 or 100, everything's 2 sig figs. 110 newtons. Okay, now let me just double check with the mark scheme that I had all my coses and sines right. Yes, I did have all of my sines and cosines correct, and I caught my mistake. So yes, 110 is correct. Suggest the changes to the forces acting on the ladder because when someone climbs the ladder. So when somebody climbs the ladder, what's going to happen is you're going to have the reaction from the ground will increase. Okay? Okay, so the reaction from G increases, and that just makes sense because you have now more weight going down. Okay. As he's climbing the components of and the direction of so if we look here, if we have somebody standing here, okay, G will have a much bigger vertical component, so it's going to be more vertical than before. And as somebody climbs the ladder, so like if he's here, for example, the horizontal component won't change, but what will change is the friction force will have to get larger because otherwise it won't be able to like balance at the moment, and because the friction force or this reaction force will get larger the higher up somebody ends up on the ladder. Okay, so a ladder is most likely to come off the wall when somebody is low on the ladder. Okay, and it's most likely to slip when somebody is high up on the ladder. Okay, so those are the points that you would have to add to get the 3 marks. So as you climb the ladder, as somebody climbs the ladder, the friction at G will increase because the horizontal force, reaction force from the wall will increase. Okay, and it all varies with time. All right, so that is question 5.